Good afternoon, learners. It is Mr. Magnoni presenting for algebraic expression this afternoon. So I hope you will be enjoying the algebraic expression presentation for today. The main topic is called algebraic expression. On the algebraic expression for grade 8, we have lesson outcomes. Learners at the end of the lesson will be able to the skill expand and simplify algebraic expressions. Use commutative, associative, dissociative laws for rational numbers and laws of exponents to add and subtract like terms in algebraic expression. Simplifying algebraic expression using manipulatives. So remember, you can do it traditional way. Also get to do some concrete of understanding of it. That's what we call it manipulatives. We use concrete materials and manipulatives in a classroom in a lower primary years, but often move away from them as students get older, giving students the impression that they are babyish, and that is small growth grown up to measure without them. This is a misguided approach, and manipulatives should be used all the way through schooling. The learners will be able to link manipulatives guide with the traditional way of teaching. So I'm going to start with the algebraic tiles. Develop your own tiles using any material. Sides of the tiles must be different colors. So you can take the A4 size paper, 2 of them, and cut it. Use a bigger square, which is be 6 by 6 when you use a ruler, centimeters. And the other one is called a rectangular shape, X tile 6 by 1 units. And the smaller square tile is 1 by 1. So these are the tiles I'm talking about. So the first shape here is representing positive one, which is this side will be 6 by 6 square. And this one will be 6 by 1. And this one will be 1 by 1. When you cut it, so you need 2 papers. Color one can be red or blue, any colors. The other one represents what? Negative values, the area of it. As you see it on the presentation there, the blue color represents positive values. So now at the end, we're going to have these results. The blue tile represents the square area. We have x units times x units give us x squared units. The rectangular tile represents the 1 unit, and the other side is x units. So the smaller tile represents 1 by 1, which is small area, which is 1 square unit. The red color represents negatives values. It will be x by x give us negative x squared units. Then the rectangular shape represents x by 1 unit give us x square unit. The last one, the 1 unit square, they represent as negative values. Now, we know when you say minus 1 plus 1 or 1 minus 1, the answer is 0. We refer as what? Inverse operations. So the result 0 is called what? Additive inverse, the additive identity. So now in also the terms of tiles, we have 0 principles. Any 2 equal tiles with different colors cancel out when you add them together. So for example, we have a blue color, which is x squared. When you add together with the red color, which is minus x squared, the results of it give us the zero principles, which is 0. Also, continuation again, if we have any two equal tiles with different colors again, for x now values, we have x, which is positive x, and also negative x. When add together, the results give us 0. And also 1 minus 1 also give us 0. This is called a 0 principle. So when we combine the two tiles, red and blue, the results when you add each other give us 0 principles. Now, represent the following algebraic expression using algebraic tiles. Now let's start doing what representation of it. Remember, x refer as what? Rectangle. 1 is small square. So now when we represent this one, I'm expecting you to have what? The rectangle, which is x by 1, and also what? The small square, which is positive. Next one, we have 3x plus 7. So in this scenario, we have how many rectangles we're going to have? We're going to have 3 rectangles. Then plus how much small squares we're going to have? 7 small squares. We're just doing representation. This is our 3 rectangles, which represent what? X by 1, x by 1, x by 1. So we give us 3x. Then now how many small squares, which is 1 by 1 unit, is 7 square small units. Now first task, second task again, we have what? X squared plus 4x. So x squared represented by this bigger square, which is x times x, give us a bigger rectangle. But because it's positive, we're going to have what? A blue big square. Plus 4x means how many small rectangles? It will be 4 rectangles. 1, 2, 3, 4. Then we have x squared plus x plus 1. Now to represent this one, we're going to have what? Big square plus a small 1 rectangle and 1 small square. Because all of them are positive, will be what? Blue square, blue square, followed by this rectangle, followed by a small unit. So this is called representation of what? Using algebraic tiles. Now we continue again. Now with negative x squared minus x minus 1. So because negative x squared is negative, we're going to represent it with a negative block, with the area of it will be what? Negative. Then also a rectangle again, the area of it will be negative. Minus 1 also a smaller side will be also, small square will be negative. We have minus x squared, negative x, and minus 1. This is how we represent it. Then now let's look for now our activity, which is based on addition of algebraic expression, as we'll be able to see our outcomes of it. Represent expression x plus 1 and 2x plus 4 using algebraic tiles. Then at the end, we might combine the tiles to get the sum. So in short, I want to add the 2 now to see how much will be my results. First, I'm going to represent x plus 1. So x plus 1, you have how many rectangle? 1 rectangle and a small square, which is blue. And 2x plus 1 also be representing with it 2 rectangle and 4 small squares. So it's plus 2 rectangle and 4 small squares. Then the solution, now we're going to count how many rectangles we have is 1, 2, 3. How many small squares we have? 1, 2, 3, 4, 5. So means our results at the end, we're going to have what now? 3x plus 5. This is how you add using what? The algebraic tiles. So let's continue. Task 2, 4x minus 3 and 5x plus 3. Using tiles and write algebraic expression, sum for the answers. So same result again. We must first represent 4x minus 3 in terms of algebraic tiles. So how many tiles we have? 4 tiles. 1, 2, 3, 4 for the rectangle for x. Then minus 3 means what? Now we're going to have what? The negative tile, negative color will represent negative 3, which is small unit, square units. Then 5x plus 6. So in this side, we're going to have what? 5 rectangles and also 6 small squares. We're adding together now. Let's count it. 1, 2, 3, 4, 5. Then let's put how many small squares? 6 small squares, which are positive. Then now when we add together, so we just count the number of squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then now we're going to have what? 4x. So how many squares here? How many rectangles? We're going to have what? 9 rectangles. So these are our solutions. 9 rectangles. How many? From now we subtract 3. So our results are going to have what? 9x plus 3. So we must take away from 1, 2, 3, 4, 5, 6. We must take away the 3 rectangles. We are left with what? 3 rectangles, right? So let's continue. Now we go for the next task. Say x squared plus 3x minus 2 and 3x squared minus 4x plus 1 using the tiles and write algebraic expression, the sum of the answers. Let's see. So now we have x squared and 3x squared. So first let's represent x squared plus 3x minus 2. So we're going to have x squared square block, which is x squared. Rectangles here, there are 3 minus 2 small units, small blocks. Then 3x squared minus 4x plus 1 means that how many square blocks? You pick 3 big ones. Minus 4x means we have 4 rectangles plus small box. So the results is, let's count again. So we're going to have 1, 2, 3, 4 rectangle, the square boxes. And how many rectangles? 1, 2, 3. Then the red ones is 1, 2, 3, 4. So now because we have x squared plus 3x minus 2. So when we need to subtract and see how much the result we have. So when we check here, the red box, which is the rectangle part of it, will remain as negative. Then the blue and red give us 0, blue and red 0, blue and red give us 0. So for x values. So in this case, when how many boxes we have here? We're going to have 1, 2, 3, 4, the one of x squared. Then we have also 1, we are left with what? Negative x. Then also again, we are left with what? Negative 1 for the 1 of the square units. So this is our result we get. Minus 4x squared minus x minus 1. Now, we go to the traditional way of working out now without using algebraic tiles. So this is what we have. So we have x plus 5 plus 2x plus 1. So in this case, we look for what? The like terms. So remember, if you're looking for algebraic tiles, you can able to see that x and 2x represent the like terms of it. So in this case, we're going to say x plus 2x give us 3x. Then 5 plus 1 give us 6x. So this is how we represent it, your solution. 3x plus 6. This is called what? A traditional way of representing the solution for additions. Next one, we have x squared minus 1 plus 3x plus 2. So if we check out this one, x squared does not have any pair. There's no any like terms. So in terms of square box, it will be only one box, which will remain as what? As x squared. And also 3x, in terms of box, we're going to have what? 3 rectangles. But it means that the like terms here will be minus 1 and 2. is what we're supposed to add each other. So we have x squared plus 3x plus 1 is our sign. 2x minus 3 plus minus 2x plus 3. So in this case, minus 2x plus minus 2x, in terms of the rectangular box, 2x, how many red, it will be blue blocks, is it 2? Then minus 2x will be also red rectangular box. So when we remove it, become the zero principles, give us 0. But in this case, we can say now 2x minus 2x give us 0. Minus 3 plus 3 also give us 0, using the additive properties. Then 2x squared plus x minus 4 plus x squared plus 3x plus 1. So our like terms here is 2x squared plus x squared, x plus 3x minus 4 and plus 1. So our results will be 3x squared plus 4x minus 3. So now we can able to link the algebraic types with the normal traditional way of addition of terms, like terms and unlike terms. So now let's look for the next activity, which is based on subtraction of algebraic expressions. So in this case, let's start firstly looking how to represent 4x plus 7 using algebraic tiles. So in this case, how many tiles we're going to have? We're going to have 4 rectangles plus 7 small squares. So we're going to have this way. This is how we have. Then our next task now say, now use slide number 17 to take away number of tiles that represented x plus 3 and what expression you left with. So in this case, this our original algebraic tiles that we were having was 1, 2, 3, 4, 4x plus 1, 2, 3, 4, 5, 6, 6. So now we must take away the x, which is this one. Then what we also must take away 3, which is 1, 2, 3. So in this case, when we take away, we're going to have what? We'll be left with this 1, 2, 3 x and 1, 2, 3, 4 units. So this is our result we must obtain at the end, 3x plus 4. So this is just a basic operation when you subtract. It means that we must take away what we have from the original when you subtract. It's not the same as when you add. So let's look for the activity. So we say subtract 2x minus 4 from 6x plus 5. Use algebraic tiles. Remember, first we must represent 2x minus 4 in terms of algebraic tiles, and also represent 6x plus 5 in terms of algebraic tiles. So this is what we have. So we have this our algebraic tiles. We have 6x plus 5, 1, 2, 3, 4, and also have 5 positive tiles. So now let's separate it. So take away that, give us 2x minus 4. When we separate, we are left with 4x plus 9 when we separate. Separate x squared minus 2x plus 7 from 5x squared plus 8x plus 4 using algebraic tiles, and write algebraic expression for the subtractions. So we have 5x squared plus 8x as our result. So what we have, so at the end, we must take away for this one. What we have here, we have 1, 2, 3, 4. This is 5x squared. Now we must take away x squared. Then we have minus 2x plus 7. This is our result you obtain at the end. So the red ones means we must take away. This is our results. So all this must be taken away from x squared plus 2x plus 7. So our results will be 4x squared plus 10x minus 3. So now we go to again for subtractions without using the normal way. 9x plus 3 minus x plus 2. So we're going to say 9x minus x, 3x minus 2. So we have 8x plus 1. 2x plus 8x minus 9 minus into x squared plus 5x plus 9. So we use also distributive law. We have minus x squared minus 5x plus 9. So this will take away from this one. So we have x squared plus 3x minus 18. The next one is 2x squared plus x minus 4. Subtract x squared plus 3x plus 1. we must take away from this side again. We subtract using deductive law, minus x squared minus 3x minus 1. So we have the result of x squared minus 2x minus 5. So a summary now for the wrapping up. The terms are separated by the positive signs. Keep in mind that the variables are symbols in the expression, constant terms in the terms independent of variables, and coefficient is the constant term of the variable. Now, as a learner, you must avoid the following. When you're simplifying expression, do not treat 5x plus 7 as 5 plus 7, which means you are adding now something like the like terms, which is not be the same thing. This result is equal to 12. Do not think of algebraic letters as object. For instance, 5x plus 4y is not the same, because what happens, some of the learners assume that to be equivalent to 5 oranges plus 4 apples. But then now they say 5x plus 4y is equals to 9xy, which is not the same, that one. When we create this one, give us a problem when we go for multiplication properties. Use multiplication operation, which is 5x plus 4y, give us something different, which is no meaning of it. Now at the end of these slides, we're going to get what? The quiz, and you need to complete it and submit it. Thank you very much for listening to me. This is the end of the presentation. Thank you.